Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you Trigonometry Part 2. Trigonometry is a branch of mathematics which deals with the study of triangles. Let's learn more about trigonometry. In today's class, I shall be teaching you the definition of special angles in trigonometry. Also, you will learn about the application of special angles to solve problems in right-angled triangles. What are special angles? Special angles are angles which the exact values of their trigonometric ratios can be determined without using a four-figure table or a calculator. The special angles in trigonometry are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Please take note of these special angles. Next, let's learn about the proof of trigonometric ratios of special angles using a right-angled triangle. Firstly, let's learn about the proof of the trigonometric ratios of 30 degrees and 60 degrees. Here, let us consider an equilateral triangle with sides of 2 units in length and each of the angles being 60 degrees. If you split this equilateral triangle into 2 halves through the 60 degrees, you are going to have a right-angled triangle having the angles 60 degrees, 90 degrees and 30 degrees. From Pythagoras' rule, the length of the sides of the right-angled triangle formed are 2 units, which is the hypotenuse, while the other 2 sides becomes 1 unit and √3 units. Considering the 30 degrees in the right-angled triangle, the opposite side is 1, the hypotenuse is 2, while the adjacent is √3. For the 60 degrees, the opposite side is √3, the hypotenuse is 2, while the adjacent is 1. Now, using this right-angled triangle to tell the trigonometric ratios of 30 degrees, sine 30 degrees becomes 1/2, representing the opposite side divided by the hypotenuse. Tan 30 degrees becomes 1/√3, representing the opposite side divided by the adjacent side. This can also be expressed as √3/3. While cosine 30 degrees becomes √3/2. Please take note of all these trigonometric ratios for 30 degrees, which are expressed in fraction form, or surd form, or square root form. Next, using the same right-angled triangle for 60 degrees, sine 60 degrees becomes √3/2, representing the opposite side divided by the hypotenuse. Tan 60 degrees becomes √3/1, representing the opposite side divided by the adjacent side. This is equal to √3. While cosine 60 degrees becomes 1/2, representing the adjacent side divided by the hypotenuse. Please take note of these trigonometric ratios for 60 degrees. Next, let us consider this right-angled triangle for 45 degrees. This right-angled triangle is also an isosceles triangle, with the equal sides being 1 unit each. From Pythagoras' rule, the hypotenuse of this right-angled triangle is √2 units. Since the 2 complementary angles in this right-angled triangle are equal, they have to be 45 degrees each. That means the opposite side is 1, the hypotenuse is √2, while the adjacent side is 1. Hence, sine 45 degrees becomes 1 over √2, representing the opposite side divided by the hypotenuse. Tan 45 degrees becomes 1 over 1, representing the opposite side divided by the adjacent side. This is equal to 1. While cosine 45 becomes 1 over √2, representing the adjacent side divided by the hypotenuse. Please take note of these trigonometric ratios for 45 degrees. Here is a summary of the trigonometric ratios of the special angles. Talking about the sine, the cosine, and the tangent values of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Please take note of all of them. Next, let's see some examples on how to find the length of the unknown sides of a right-angled triangle using special angles. In our first example, let's find the length of the side marked X in the triangle above. The triangle is a right-angled triangle with a 30 degrees. The opposite side is 10 while the adjacent side is X. Applying trigonometric ratios, tan 30 degrees becomes 10 over X, representing the opposite side divided by the adjacent side. Without using 4-figure table or a calculator, tan 30 degrees is 1 over √3. When you cross multiply the equation formed, X becomes 10 √3. I hope this solution is clear to you. In our next example, let us find the length of the side marked X in the triangle above. The triangle above involves two combined or overlapping right-angled triangles. From the solution, starting with the small right-angled triangle, cosine 60 degrees is equal to 5 divided by the hypotenuse. Without using a 4-figure table or a calculator, cosine 60 degrees is equal to 1 over 2. When you cross multiply this equation, the hypotenuse becomes 2 times 5, which is equal to 10. Now let us move to the big right-angled triangle having 45 degrees. Here the hypotenuse of the small right-angled triangle becomes the adjacent of 45 degrees in the big right-angled triangle. Cosine 45 degrees becomes 10 over X, representing the adjacent side divided by the hypotenuse. Since cosine 45 is 1 over √2, cross multiplying will give us X is equal to 10 √2. Next, let's see some examples on how to find the size of the unknown angle of a right-angled triangle using special angles. In this example, we have a ladder 5 units long leaning against a vertical wall. The distance of the foot of the ladder from the wall is 2.5 units. Let's find the value of X, which is the angle the ladder makes with the wall. In the right-angled triangle formed, 2.5 is the opposite while 5 is the hypotenuse of X. Using trigonometric ratios, sin X is equal to 2.5 divided by 5, which is equal to 0.5. X becomes the sine inverse of 0.5, which is equal to 30 degrees. In our last example, let's find the value of angle BAC in the triangle above. Which of the trigonometric ratios do you think will be required here? Is it sine or cosine or tangent? From the solution, let the angle BAC be equal to X. Since the adjacent of x is 7 centimeters and the hypotenuse of x is 25 centimeters, cosine x is equal to 7 over 25. I hope you got that right. From division, cosine x is equal to 0.28. X becomes the cosine inverse of 0.28, which is equal to 73.74 degrees. Please take note of the solutions of all these examples involving special angles. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic trigonometry, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.